Now, the next thing we're going to learn is about Hooke's law. So what does Hooke's law tell you? Hooke's law says that within the limit of proportionality, which I will explain to you what is that about, the extension produced in the material is directly proportional to the load applied. That means if you are plotting a graph of extension versus load, you will actually get a straight line if it obeys Hooke's law. At the end of the straight line is called the proportional limit or the limit of proportionality. So that means Hooke's law says your extension will be directly to your load only up to the limit of proportionality. That means up to the proportional limit. Once it starts to curve, it no longer obeys Hooke's law. Do you understand now? So Hooke's law means it must be a straight line passing through the origin, because when you use the word directly proportional, it means that you must start from origin 0, 0. If they just use the word proportional, then it doesn't have to start from 0, 0. It has the same meaning as varies linearly. That means it's just a straight line relationship. But if you add in the word directly to proportional, so you're directly proportional, you must start from 0, 0. So your graph must start from 0, 0. It is a straight line. Do you understand now? So what is limit of proportionality? Some people ask me, is it the same as elastic limit? In most of the cases, proportional limit is not the same as the elastic limit. In certain cases, the two limits or the 2 points may overlap, but it is not often. So I want you to understand what's the difference. Like, if you're talking about proportional limit, it is exactly the end of the straight line somewhere here. After that, it curves a little bit. Then you will reach the elastic limit. So usually, the elastic limit is slightly higher than the proportional limit. So what's the difference? When you reach the proportional limit, above it, no longer a straight line, but it is still elastic. So what does elastic mean? Elastic means the material will return to its original shape and size once the deforming force is removed. That means as long as I load the material all the way below the elastic limit, it could be along this straight line, or it could be along this tiny part here, which is a bit curved. But if I release the force, it will return back to the original shape. So it's not the same. Proportional limit is end of straight line. Elastic limit is the point beyond which you have permanent deformation. You can never come back to your original shape and size. So don't overlap. They are not the same. Okay? In certain unique cases, they may be so close together that it seems that they overlap. Do you understand? Okay? Right. So that is actually Hooke's law. So which gives us the equation what? So since your f is proportional to x, so when you introduce a constant, is f equals to kx, and that's how we get the expression for k, which is f divided by x. So what's the definition of k? K here is called a force constant or a spring constant. You can call it either force constant or spring constant. So what's the difference? It depends on what material you're using or what object you're using. If you're using a spring, you're finding the extension versus force graph for a spring, then the gradient of this graph is what? Okay, I'll tell you later. But if you're using a spring, then the constant here is called a spring constant. But if you're stretching a wire, let's say a thin copper wire, then K here is called a force constant. So force constant is like a general term, and spring constant is specifically for springs. If you're using wires, a long piece of wire, you don't call it spring constant, you call it force constant. But it's same formula, f for dy by x, okay? So if you have a graph of x versus f, what does the gradient give you? It doesn't give you k, it gives you x divided by f, which is 1 over k. So that means if they give you this graph, then the spring constant is 1 over the gradient. But if they give you force versus extension, then it's straightforward. Your gradient will be equals to k. You understand the difference now? Okay? So when you say the gradient is, when we say the spring constant is 1 over gradient, we call it the reciprocal of the gradient. It means 1 over gradient means it's a reciprocal of the gradient. Okay, so you hear this term, it means 1 over gradient. Okay, that's all I want to say. Now, gradient means you can take any 2 points to find the gradient because it is a straight line passing through the origin. So no worries, you can take any 2 points to find the gradient. Okay? Now, K, which is spring constant or force constant, is a measure of stiffness. So what is stiffness? Stiffness is the resistance of material to changes to its shape or size. So the stiffer it is, the harder to change its shape or size. Do you understand? What's the opposite of stiff? Flexible, right? Can easily change. So anyway, let's talk about this spring constant K, how to get it. So let's say for one spring, we apply a load of 1 kg, and the spring constant is K and the extension is X. So let's say this is my reference values. These are my reference values. When you connect springs in series, which means to say like this, one after another, and we apply the same load of 1 kg as here, what will happen to each of the spring? Each of these springs? Will it also take 1 kg or will it take less than 1 kg each? Each will be 1 kg. Yes. Why? Because if you are this spring, you'll feel pulling down by 1 kg, right? But since you are not falling, that means you are not moving down or moving up, that means the upwards force must balance your downwards force, right? That means the top spring is pulling you back with the same force. So according to Newton's third law, if this top spring is pulling the bottom spring with equivalent to this force, then wouldn't the bottom spring pull the top spring downwards with the same force? So therefore the top spring will also experience as if 1 kg. Okay, so every time you connect in series, they will all take the same load. That means you got 4 or 5 of them in series, each will also experience a force equivalent to 1 kg each. Do you understand? Okay, so what will happen is, if you're talking about just a single spring, 1 kg produces X, so this 1 kg also produces X, right? But this also 1 kg, so it also produces X. So your total extension is 2X. So we can find the combined spring constant. That means the combined spring constant of this system. How? By finding the extension first. So the technique is always find the extension first. So remember, once you know the extension, you can find the K. You know why? Because the formula for K is F divided by X, right? Since I'm applying the same load here as here, so the force is constant, so my K will be inversely proportional to the X. So therefore, from X double to 2X, since your K is inversely proportional, so the K will become half K. Do you understand that? So you can find the combined spring constant easily by always finding the total extension first. Then you inverse it to get your new spring constant. Okay? Now, example, if I give you another spring system, let's say 3 in series, so I just draw the side. So if you have 3 in series, and you also apply 1 kg, sorry, yes, 1 kg, so what will be the total extension? 3x. So what is the combined spring constant? K divided by 3. Always inversely. Okay, now, so let's talk about springs in parallel. Parallel means you put side by side. So if you put 2 springs side by side and carry the same load here, then wouldn't this load be shared equally? Like 2 people carry a heavy object, it's not so heavy, right? So each will take half the load. So this one will take half a kg, this will take half a kg. So which means to say, what will be the extension here if you're carrying half the load? Half the extension, right? So in other words, this will take x over 2, this will also take x over 2, right? So what is the total extension? So some people get confused with the term total extension. They said, this is x over 2, this is x over 2, so total is x. Correct? No? Wrong. Because total extension is not adding this way, it's measuring from top to bottom. How long does the spring extend, the system extend? So from top to bottom, it only extended by x over 2. You don't have to go and add both sides. Do you understand that? Okay? So therefore, since your extension from x becomes x over 2, that means you divide by 2, and your k is inversely proportional, so your k becomes 2k. Understand that? So which means to say, if I have 3 springs in parallel carrying the same 1 kg mass, so what will be the total extension from top to bottom? X divided by 3. So what is the new spring constant? 3K, inversely proportional. Do you understand that? Okay? So if you look at this example, so let's say we have 3 springs now, but these 2 in parallel, then connected to 1 more in series. So how to find the new combined spring constant? The technique is always to find the extension first. Always find extension first. Then only find K. So if one spring here connected to 2 springs here, so since this is in series with this, so this will take 1 kg, this will take 1 kg. Agree or not? So since this takes 1 kg and is split half-half, what is the extension for the bottom? X over 2. And since the top here takes 1 kg, what is the extension? X. So what's the total extension? 3x over 2. So what is a new spring constant? Since it is inversely proportional to your extension, so since this is 3 over 2x, the k will be 2 over 3k. That's how we now find the new spring constant. Do you understand that? Okay, so that is how you calculate springs, K for springs in series and parallel.